Hi folks, welcome to my 8-Bit Retro Journal. Today we're going to continue in part 2 our journey back into the 80s looking at multitasking. In part 1 we compared the Sinclair QL and its preemptive multitasking kernel to the Multifinder from 1995 on a Macintosh using cooperative multitasking, and we tried to show the difference between and the behavior of preemptive versus cooperative multitasking. Today we're going to look a little deeper on the Mac and first look at some programs that existed back in the day, Microsoft Word, McDraw, and others, and see how well they handled cooperative multitasking by seeing how that little Globe program we're using, how well it runs. And then we're going to dig into some code. We're going to look at some C source code to actually show you, how do you implement cooperative multitasking. We're going to compare it to C source code that was written on the QL on the same program, just to show you the difference between writing a program the way you might expect to write it and writing it the way you would have had to written it to make it work in cooperative multitasking, to show you the challenges and the hurdles you faced. Writing a good program, good code so programs behave properly, and even then it was still somewhat difficult, especially when you're writing something like an interpreter. So that's what we're going to cover today, so let's get going. What I want to do next is just go through some applications that I already have, just to sort of show how it interacts with this only one that actually truly background tasks. And so you can see that I'm going to throw Moye on. Moye and Climate kind of slow this down accordingly. Simple text, if I have nothing open, if I open something, oops, I just lost it behind the, it does a pretty good job. Not as fast as when it has nothing open. It's much quicker. I did try other applications, like, for instance, Word. I have Microsoft Word on here. Microsoft Word actually doesn't do such a good job with it. Actually, if you look at this, you'll see that once Word is open, that's got to open up a bunch of things. Of course, while it's opening up, and that's perfectly acceptable. This happens on the QL too. If you're doing disk I/O, sometimes you have to say nobody gets, but it's who's in control of that, obviously. And you'll see that as this is running, eventually it's going to get, but you can see it's much slowed down. So even though we're not doing anything in here, and I went through a few of these applications just to demo that. So some do better than others. Now ThinkC did actually a nice job. So if I open up a project under ThinkC, I don't want to have oodles of windows open, so I'm going to close all the ones before. But if I open up ThinkC, you'll see that it actually does a really nice job. So obviously they wrote a compiler, so they probably know best how to. And even if I open up Command C, you'll see how even at that, it's still going really fast. So they're doing something. They've realized that if you're doing text editing, you don't really have to be doing a bunch of other things. So they specialize your code. But again, that's one of the problems in cooperative multitasking, is you're relying on the coders to do a better job. And even folks at Microsoft, you can see, really slow things down. There's as far as programs goes, McDraw is another interesting one, right? It's this is actually now the Claris version. I think Apple gave it away to Claris to continue to modify and develop. You can see once it's open, unfortunately it covers things up, but it definitely takes up a little bit more resources than you wanted to. And it also sort of changes the resolution on my Globe in terms of, so a little bit of graphics issues sometimes, even that the Macintosh has. WordPerfect was a competitive word. Let's see how it does. And we have, fortunately, it covers the whole screen. And we can go show ruler just to make it look more like the Mac. Does a better job, right? Yeah, than Word did in terms of speed. And let's see what else we have. There's again just a bunch of HyperCard. This is written by Apple, so you'd expect. So this was sort of a pre-World Wide Web link system where you could create these help pages or educational pages locally on your computer to create hyperlinks. And it's a little choppy, but it's doing okay. Okay, you'd expect that from Mac folks. I mean, they should know, but sometimes you have different folks running. Canvas actually is expired. It's right there. BB Edit was a famous editor. And yeah, there's corruption in the, I'll just do a new. That was a famous freeware, shareware editor that we used a lot. That kind of slows things down. No different from what Climate does, my program. And utilities. Let's see what I have on the utilities. Yeah, just res edit. So that's the resource editor that the Mac. So this is a Macintosh piece of software. So we can just see how that does, right? And yeah, we've got a nice little animation. And I'm just going to open up Climate because it has a resource fork, and then you'll see how. So this does really good. So you would expect the Mac folks, especially Res Edit, Resource Editor, they probably knew what they were doing when they were developing it. Oh, did I just? No, okay. You can actually quit the Finder, and I just thought I quit the Finder. So I think, and then, yeah, these are just nothing special here. These are just disk copy. Yeah. Under miscellaneous, I've got just some system tools was a way to actually see the load on the system, which is a pretty handy little tool. And it's just going to give you a bar graph down here. And again, it does a terrific job because it's probably not doing too much. It's just polling once in a while. I don't think it'll slow this down. You can see it's going to start creating a graph down here of the load on your CPU. So that was a nice little app. Let's see what else. Now the Mac did have background processes that were headless, so they did exist. And I did write one of the other tools that I wrote besides Climate was CPU Doubler, which tried to sort of add. I'm pretty familiar with the kernel on the Mac because I actually hacked it with this application. And what CPU Doubler does is it actually hacks the entry point for cooperative multitasking to give a bit more control, even though it's still cooperative, but you might task swap programs in the background. You might not give them as much access to the CPU and just say, nope, next. And you can see under Customize, you could edit processes. And here you can actually see what's running. So we have the Finder running, which is, and Globe, but you also have Cron Manager, which is a faceless background application. So this is another tool that I wrote. And there can be other faceless background applications, and that one just basically does what Cron does. So I spent a lot of time in the 90s trying to Unixify the Mac before it went over to writing a bunch of applications like Climate, CPU Doubler, Cron Manager, to make life easier on the Mac. But this allowed you to customize, and then right, you can edit the processes. You could give it priorities, and these are all relative. So this means Globe should have twice as much as everybody else. And if I actually edit this and give it 8, and now you'll see that when Globe's in the background, it's actually going to run much slower because it's gotten less process time compared to Cron Manager and everything else. And so this allowed you to make some changes on that. But let's give it back. It's 32 as default. So if they're all equal, so basically what this is saying is that Globe should get twice as much time as the Finder and Cron Manager. If you do that, you'll see that it gets its nice runtime back. And if I turn this off, actually, I don't think it's going to change much. Yeah, So that seemed to be what the default was. I had it turned off for this demo, but the CPU double did this by basically hacking the entry point to cooperative multitasking, which is the get next event. I'll show you that next. And if a process in the background was asking for time, I might say nope and skip it, causing, and again, when you skip that, then the CPU has more time in the foreground. It's still cooperative multitasking, but it was at least a way to control it a little bit more. That's a program that I wrote. In any case, and so these are some of the programs that are out there. I think I looked in everything else here. Oh, Jigsaw was the interesting one. If I use Jigsaw, you'll see that, and again, if I open it up, it takes a while to, it's creating puzzle. Notice while it's creating puzzle, it's not actually reading it from disk. It actually takes the whole process over, and once it's there, it runs. And I wanted to see, this was written, yeah, and after Multifinder was already out. So, but if you do start a new puzzle, it takes a while as it's creating puzzles. Notice that it is also stopping, so it is not behaving itself properly with regard to cooperative multitasking. It sort of stopped. You'd think that it would somehow maybe throw out a get next event. And so now it's back to being normal. And so if I actually solve this puzzle, you'll notice that, again, while it's solving it, everything is kind of sitting in the background waiting until it's solved. This is going to take quite a long time. Now, if I click on here, it'll automatically solve it and you're done. But again, here's an example of a program that doesn't behave itself properly because this globe, which is the only one thing that's been written so that it actually multitasks cooperatively in the background, works. I mean, there's plenty of other programs. It's just the ones that I have and I've shown you that don't work. So let me go back to, and again, I'm just going to let this run just to let you show. So this is definitely been slowed down a bit, but that's okay. It's still chugging away, and I'm happy to demonstrate that. So again, this is how modern Windows, Unix, Linux, and Mac OS X do multitasking. 1983. Yes, the graphics are crappier. You know, you can see it only has 4 colors in this, which is red, green, black, and white, and then in the stipple patterns. You can really see that here. Obviously, when I showed it to you on over the original QL through Composite, it kind of blurs that all. But the artifacts were just too bad. But yeah, so certainly this has 256 colors. This has 4 to 8. So there are differences, but we're not trying to compare the Mac II, which cost almost $5,000 in 1988. It was discontinued, I think, in 1990, to a computer that cost a few $100s in 1984. I'm just trying to compare the essence of the operating system. Here, the Finder being the Finder having 8 megabytes of memory to work with, and the QL being created in 1995, the QL operating system 1983-84, 48K of ROM. So that's pretty impressive. But let me, I'm going to complete this by now going into I'll leave this one, just to show you actually how cooperative multitasking works, because I've also heard people say, all you have to do is you program it properly and you're good to go. It's really not such a big deal. Well, programming it properly is not easy. So let me go back on the projects, and I'm going to try to keep everything closed so that I don't run into the window mess here. And I'm going to go under History and QL, and I'm going to leave this window open, and then I'm going to go under Combo. So this was the final version that I got. When I compile this, I get this. And even though I don't have the original project, when I compile this and make a few changes, I get that. So let's go back into Command.C. It's going to be, again, loaded up in the simple text, which I unfortunately closed. And I just wanted to show you how I got it to multitask. And, you know, I didn't go into the parser and try to find 50 different places to throw in the appropriate code. And you can see, and I'm going to do the font size. I'm going to select it all again. I'm going to do the font size as, I think it's 9. And the font is going to be Monaco, just so we get an apples to apples look at the, no pun intended, Monaco. And then we can kind of shrink this a little bit. Unfortunately, unlike Notepad, this doesn't let you do a wrap or a no wrap. So I can only shrink it so much. So stick it down here for now. So again, this represents this code. And I'm not actually gonna look at the other ones here. So I can close this up. And then open up this project. And here I'm gonna have to kind of hop around. So you can see that Command C, Expression C, Oxy, these were the original ones, including a header file. And I've also added file manager stuff to actually allow me to do all the file manager stuff for getting directory listings. But then the stuff up here is really the windowing stuff. And this is actually the stuff that's gonna deal with the cooperative multitasking. So if I open up Command here, you'll see that this is not where the main code is. And unfortunately, my scroll wheel doesn't work. So this is a little bit of a pain to have to deal with. And it's actually the emulator, not even my, I have another emulator that I can't get to real time, get to run real time, but it will accept the scroll wheel. But if I move this here, and then I move this up here next to it and scroll down, just to really point out the important differences, and it's right here. So this loop hasn't changed other than right here. And then notice here, if I hit Q or break, and I guess I shouldn't have, I spoke too soon. Let me do one more, oops. No, I didn't want to do that. I wanted to, yeah. I gotta open this one more time. Projects. And close this, CL. Close that. And history, and we'll see if I zoom through this, and then QL. So maybe I'll leave this open. The header file, and you'll see that QL. The reason I want to show you the header file is that I've defined QL break, QL stop, QL code. These are just key row functions, which are QL system functions that use the keyboard matrix, and it just says if this key 2 on key row, which is a control key, is pressed, and key number 8 on key row 2, which is the, in this case, control B, and this is, well, that's actually control C. I think I changed it to control B. And this is control S, and this is control Q. And so that's all I'm looking for. And again, on the QL, I literally go into this tight while loop. While I don't get the key row, I just stay in that loop. Not a care in the world about, hey, the operating system should take care of me. Here, on the other hand, if you look at now this is the implementation of climate, which behaves itself properly. I check to see if I have a Mac keyboard event, then if I got Mac stop, then I go Mac go, and if I do, then if I wait for Mac keyboard event, and if it's break, then I get out of it. But these two things, the keyboard event ones are key. So again, I'm going to close this for now. I'm not going to save it. And if you look at now the header file here, and the header file is going to be this one right here. You can see that the way these have been written, Mac keyboard event is actually get next event. Specifically, I'm calling get next event. So now here, right here, I'm actually doing that. So the get next event call is that magic call on the Macintosh that relinquishes control back to the operating system. So that is your cooperative call. You intersperse these in the right place, and your code's going to run fast. But you have to do it. And I do it right here. So when I'm in this tight loop, I keep calling get next event. And that's why when I hit Control B in this code here, so when I'm running this, and just to make sure we can still see. All right, so when I'm 10 for I equals 1 to 100, 20 print I, 30 next I run, and I do Control S for stop, I am now in this tight loop where I'm calling get next event every time. You can see, even with that, it's still not running super fast, but I'm not stopping it, right? And so I actually don't know what they're doing. They're doing a really phenomenal job. I don't know if they're calling multiple get next events. I suppose they could do that. But anyway, I had to do that. If I didn't do this here, I would freeze up everything. And I'm basically waiting to get the next keyboard event. And then if it's a Mac break, which would be Q, I run again. All right. So that's how this works. And I now unfortunately have to wait until this finishes running. No, actually I don't. I can just do, yeah, this will break up. So that's how that works. Let me quit this again. Whereas, and then the other one is this Mac keyboard event. And the Mac keyboard, I'm sorry, actually, I take it back. The Mac keyboard event is the thing that actually calls get next event. It's this wait, so I know now why it's slow. Wait keyboard event actually is a call to my main event loop, which, so likely to speed this up, to make this go fast, I should have likely just had this also be a Mac keyboard event. In other words, just call get next event and look for a key down and then grab that to see if it's Control S or Control B Q. Whereas actually when I'm in this tight loop, I'm calling, oh, and the reason I do that is because when I'm breaking, I want to be able to, right, so I guess I shouldn't have quit this. So the reason I do this is 10 for I equals 1 to 100, 20, print I, 30 next, 30 next I, run, Control S. And so now I'm stopped, but it allows me to be able to handle the menus. So that's why I have to call Mac keyboard event, wait keyboard event. And here, instead I call wait, so that, and I'll show you what that looks like. But let's see, I can't go in this again. Good. Maybe I'll leave this open this time. Fortunately, I can't minimize it. No, I'll quit again just because it's just too. No, I don't want to save it. And so the what the wait keyboard event, which is main event. So this is in cl.c, and what that does. So this is where my main loop is actually, and you can see that here's where I initialize everything, and then after everything's initialized, I call a init parse, and then I do parse, and do parse ends up then calling. So do parse is the function call right above this, and it does it checks to whether I want to add a line, and if not, I call a parse command, and then I'm in this while loop if I'm actually parsing a bunch of commands or running a program. So from the main, it's a pretty quick entry point into that. And again, in here, I just do parse and parse command right from the start. But here then, and this is been a little unusual because usually the entry point from your main is straight into this one, which is your main event loop. And this main event loop is the one that then handles your, this is generally would be, instead of an if, it would be in a while loop, and you would just grab get next events. I chose to have my while loop be parse commands and then call this constantly there. So it's perhaps not as efficient, but I was porting something from a non-event based preemptive multitasking to a cooperative multitasking. But then it has to go and check all of these potential events, including key down. If it's key down, then I might be either Control S-ing or Control Q-ing, I might be typing something. But here's where my main event goes. So you can see that the way this is all strung together, that the key here is I need to occasionally call get next event to handle this. And again, why does my climate program sometimes lose that? I'd have to debug and figure this out. It's not well behaving. But that is in essence what you have to do in cooperative multitasking, and you've got to do it well. So here, I could, in parse commands, it calls get next event here and here, and then it does the basic parse, and the basic parse, and then it does the DOS command parse and the alias parse. If you look at that, it has to go through this entire code, and then go through this entire code, and then go through this entire code. And so that's a lot of code it has to run through. So on a slower machine, you're going to really slow the background processor down. In a preemptive environment, you might just check for clear, and now you're checking for a clear screen, And the operating system says, you're done, I need the processor back. But in the cooperative multitasking thing, it's going to have to go through, back in parse commands, it's going to have to go through this function call, which is long, this one, and come right back, and then finally gets the next event. So you have to have a pretty fast machine. And again, this is running at least 4, if not more times faster than the QL. So you have to have it. And again, I wrote this on a 95 machine that was probably 20 times faster than the QL. So I didn't really worry about that. But with cooperative, and if this were too slow, somewhere in here or in here, I might have to stick this call in. And I don't think, if I search for KBEVT in this file, I don't think it's going to oops, I'm in control mode. KBEVT, it's not going to find it. Yeah, so it didn't find it. If I do it here, find. So it found it here, and then I can find it again, find again, and that's it. So these are the only 2 places in this whole function, and the critical part is right here in this long parse. So yeah, not the most efficient. And again, if I wanted to make this more efficient, I'd have to go in and find places in basic commands to perhaps, after 5 or 6 else's, I might want to throw in a get next event. And this is the horror of cooperative multitasking. It's not only bad for the user, but for the programmer, especially if you're writing an interpreter. Imagine if you're writing an emulator. You really have to think hard and long on how to implement that. And that's what I wanted to demonstrate to folks in terms of, that say, when people claim, well, all you have to do is just write good code. It's not easy to write good code. And I thought I wrote okay code. And again, Climate does a pretty decent job, but if it's when I'm running a program, 10 for I equals 1. Well, if I just 10 for I equals 1 to 100, 20 print I, 30 next I. Again, I'm fearful of running, since I do have a bug in mind, I'm fearful of writing an infinite loop because I'm going to have to just reboot this whole thing. But here, it's behaving itself, but each time it's going through 4 or 5 lines, it's definitely relinquishing after each print, but it sort of appears like it's getting to write 4 or 5 lines. But I think it's some internal buffer in the Finder is also filling up, so you don't really see that. But again, you had to work at it, and I guess the expectation really wasn't that you were as easily able to do multitasking as you can on a QL or modern machines. And just to think, 11-year difference, obviously much prettier looking, but when it comes down to the core of the kernel, 48K kernel here, doing a really beautiful job, and then you could write code not like I just showed you, but like you would expect. Just write a loop. To me, just to finally end on this note, to go back and I'll leave everything open now since I'm going to finish up. Back to the history folder, and I find that being able to write my code this way, which is kind of the way I think about it, is how I think about it. Right, and I don't want to have to think about what's the operating system going to do. So if I want to do a stop, why can't I just have a while loop that's literally just looking for the key combination and everything else is oblivious to me? Why do I have to give control back to the operating system? Why can't the operating system take control back from me? And that's, in a nutshell, the difference between cooperative multitasking and preemptive multitasking. In any case, I hope you enjoyed this. I know it's a little messy, but this is, I got, as I said, through my work on CPU doubler, which actually hacked the kernel, I really got to know the cooperative multitasking Finder, and I was a big fan back then, mainly because this is nice, the colors and everything else, and of course my computer prior to that had some cool things in it, like it had multitasking. And if let me actually restart this. And what I'm going to do this time is I'm actually going to run the emulator in you can run it in. So this is with. I don't have the hardware for this, but people in the QL community have worked on creating hardware that can run faster. So this particular rendition now is 8 megabytes and is running pretty fast, and it's got a bunch of toolkits on there. And again, if I run the so this is now on an accelerated QL. lrun mdv2. Oops, there mdv2. lrun. Oh, misspelled it to QDOS. And you'll see that this animation is going to be, yeah. So this runs about 10 times, well, maybe 4 or 5 times faster. But you'll see the animation is just going to be like, really fast. And here, of course, I can run a bunch of these, window 150, 150, 350, 10, MDV2 CL, window 150, 150, 10, 10, MDV2 baton. So again, so if you have the MDV2 baton, if you have the power, and I do have an accelerated or a new creation called the Q68, which runs about 20 to 30 times faster than QL, and so now do I have 3 things running? Exact MDV2 baton exe. Yeah. Now 3 things running. Oops. 3 things running. I can then maybe continue. Go to 250, 40. So, and then, right, 10. I did have a nice little lrun mdv2 pyramid. Actually, I'll do it here. lrun mdv2 pyramid cl bass. Notice it stops things when it's doing I/O, and of course lrun mdv2 pyramid cl bass. And again, it's actually perfectly acceptable while it's doing, yeah, so this is going to do a little pyramid. And then here I can go lrun mdv2 clock cl bass. So this, I've basically done this to put a little clock on the top. So it just recreated its screen, and every second it checks and it changes it. So I basically just, with my window command, I was able to, so this is still a basic window. If I go, right, so this is still my basic, and I'm just running a basic program here. And then, again, I can run this program here. But so it looks like a mess, yeah, and this is running maybe 4 or 5 times faster than a standard QL. So it doesn't take much. This is maybe running the speed of this, and it looks a little messy because it's not doing screen stuff. But yeah, running baton 3 times, 2 versions of CL, and then my animation. As I said, low graphics and doesn't really do the windowing environment justice. Now, if you watch my ZX Simulator video, you'll see that I actually also have an icon control environment that gives you a little bit of that, but I tend not to use it. And it's not as well integrated, but there are other ones. There's a pointer environment, etc. In any case, this video was about multitasking, preemptive versus cooperative, and I just wanted to give folks an idea of what that meant in terms of computing. And as a modern operating systems now all follow this protocol. But back in the late 80s and through the 90s, especially with the Mac, till 2001, 2002, it did cooperative. Anyway, thanks for watching my journal today, and if you have any comments, please make them, and stay safe.